Hi, three-phase induction motor. It is mostly used in all kinds of applications, especially in industrial and commercial and residential applications. These motor used in many places. Almost it occupies 80 percentage of applications. And here I am going to give you the overview of the construction and images of different parts of induction motor. Basically, this induction motor is called as asynchronous motor. We know that the synchronous speed of the machines can be computed by ns equal to 120 f by p. Here ns represents the synchronous speed of the machine and 120 into f, that f represent the frequency of the supply voltage, and divided by p, that p represents the number of pulses of the induction machine. As per this formula, we can say that the synchronous speed of the machine is depends on the frequency and number of pulses of the machine. So the number of pulses is decided at the designing stage itself. So the machine speed is directly proportional to the apply frequency. So here they are naming this induction motor as a asynchronous machine because the speed of this induction motor will be always lesser than the synchronous speed. It will not equal to the synchronous speed. So for that they named it as a asynchronous machine. And next we can come to the different parts of the machine. And basically there are two kinds of machines are used in the industrial and domestic applications. One is squirrel cage induction motor. It is mostly used in the industrial and domestic applications, and slip ring induction motor is rarely used, and it is selected for the high torque requirement applications. And here the parts of the induction motors are classified into two main groups. One is stator and another one is rotor. In the stator, we have stator frame or yoke, then stator core, stator windings, and terminal boxes are there. So in the rotor, we have rotor core, rotor coil, bearings, shaft, and fan for providing cooling. And these are the different parts of our induction motor. And here I shown you the images which are clearly giving the structure of the different parts of the induction machine. So here you see that this is a cross-cutting image of the three-phase induction motor. So here this is called a shaft, and this is a squirrel cage rotor, and here you can notify that there is a skewed type rotor. There the copper bars are placed on the slots of the rotor, and that copper bars are short circuited by providing two end rings. So these two are the end rings and used for short circuiting the rotor conductors in order to develop the torque within the rotor. And here these represents these are the three-phase sinusoidal three-phase distributed windings. So they are not punched the winding on the single slots. They are distributed their three-phase windings over the different slots of the stator. So here you can see that there is a slots on the rotor, and there are so many slots on the stator. So they are going to distribute the three-phase windings over the slots of the stator. Okay, and in the rotor they are going to place the copper bar. So that copper bar is acting like a rotor conductor, and that copper conductors are short circuited by the end rings which are shown here. And this is called a terminal box. It is used for connecting the terminals of the motor with the supply, and this is the hook for lifting the machine or lifting the rotor, and they are calling this as a yoke or outer frame of the machine. So I overview the images of the different parts of the machine. And here you see that there are parts, so end ring or end cover and cooling fan, end bell. It is for providing the mechanical support for the rotating rotor. And these are already shown in the previous image. Yoke or outer frame of the machine, and this is the stator winding, and this is the terminal bars, and this is the end well, and we are providing it for providing the mechanical support for the rotating rotor, and this is the squirrel cage type rotor. And I show you the images of the different parts. So here you see that this is a squirrel cage rotor. It is used in the squirrel cage induction motor, and this is a image of our slip ring induction motors. Here you see that, so there is no windings on the squirrel cage induction rotor. Instead of the windings, they provided the copper bars. You can see the copper bars, and this is called end rings. So these copper bars are inserted over the slots of the rotor, and the two end rings are connected at the at the outer terminals of the copper bar, and this provides the short circuit for the rotor of the squirrel cage induction machine. And here you see that the slip ring induction motor is made with the help of three-phase windings, and they are providing the three-phase windings over the slots of the rotor, and they are using the skewed type rotor in order to avoid the magnetic locking in between the stator and rotor, and these three are the slip rings. So this is used to provide or connect the external resistance with the rotor circuits. So still now I have overviewed the important spots of the induction machine, and here these are the images of the stator. So stator constructed with yoke and stator slots, and these are the images for the rotor circuits. And you can also find the animated videos for the working principle of the induction motor or any kinds of machines, and from that you can clearly understood what is happening within the machine. And you can see that the copper bars are there, and the copper bars are short circuited by the end rings. But here they provided in the slip ring rotor, they provided the windings, and the winding terminals are connected with the slip rings, and they provided the brush holders. So this is about the construction of the machine. And finally I show you the images of ball bearing and roller bearing, which are used in the low power machines and high power machines. So this is a slip ring induction rotor, and this is the ball bearing and roller bearing. So the ball bearings are used in the small power machines, and for the high power machines they are preparing the roller type bearings. Thank you.